Welcome to grade 12 physics course. In this course, we're going to learn about a variety of topics. We're going to learn about forces and motion in Unit 1, energy and momentum in Unit 2, and we're going to explore electric, gravitational, and magnetic field in Unit 3, and in the last unit, Unit 4, we're going to learn about the wave. In this lesson, let's take a look at kinematics. So, what is kinematics? And the answer is, the study of motion is kinematics. To begin kinematics, we'll explore simple motions in 1 and 2 dimensions. Later in this course, we will learn more complex types of motion, like centripetal motion. First of all, let's learn about scalar quantities. Scalar quantity refers to quantity that has magnitude but no direction, and scalars can be positive, 0, or negative. A great example of scalar quantity is speed, which can be classified into instantaneous speed and average speed. And we use the formula v equals d over delta t to calculate the average speed. And the Greek letter delta denotes the change in a quantity. Therefore, delta t represents the time between events, or the elapsed time. Here's a question they can try, but I'm not going to go over it because it is too basic for you. But keep in mind that in grade 11 and grade 12 physics, you must apply significant digits unless the question explicitly states that you don't have to do so. And we're going to cover significant digits in the next episode, so don't miss the video. Vector quantity refers to quantity that has both magnitude and direction. For example, position, displacement, and velocity are common vector quantities in kinematics. To illustrate this, let's say the position of the cyclist at D1 is 338 meters to the west of the reference position, and say after 2 seconds, the cyclist moves to this point, D2, and the position of the cyclist at D2 would be 223 meters to the west of the reference point. And therefore, the displacement of the cyclist would be the difference in these two numbers, plus the direction. So the displacement will be 115 meters to the east. Velocity is a fundamental vector quantity that describes the rate of change of an object position with respect to time. Since it is a vector quantity, it involves direction as well. When a velocity remains constant, meaning the object moves at a steady speed in a consistent direction, it results in uniform motion. In this case, velocity is calculated as the displacement divided by the time interval, or delta d divided by delta t, as shown on the screen. Velocity at any particular instant is called instantaneous velocity, and we're going to talk about it in the next slide. Providing the position and time graph, how can we calculate the instantaneous velocity at t equals 2? And you should know about position and time graph from your grade 11 physics course. And the answer is, we need to find the slope of a curved line at t equals 2. So to find that, we need to draw a straight line touching but not cutting the curve at that point. And a straight line is called a tangent to the curve. And the slope of the tangent to a curve on a position and time graph is the instantaneous velocity. Here, I've drawn multiple lines. As you can see, all of them cross this point here. But which line do you think is the tangent line to this point? Here, we just calculated the slope of the tangent line based on the nearby points, which are t equals 0 and t equals 4. But this method is not very accurate though. I'm going to introduce a better way of solving the slope of the tangent line later in this course. By the way, in the notation used in calculus, the delta symbols or the triangle symbols are replaced by the d symbols to represent infinitesimal or extremely small quantities. A great way to demonstrate distance and displacement is by examining this question here. So in this question, Given that d1 equals 22 meters and d2 equals 11 meters, find the total distance traveled and the total displacement. Finding total distance traveled is pretty easy and straightforward. You just simply add up these two numbers and you will get 33 meters. However, finding total displacement can be pretty complicated. It involves both cosine law and sine law. The total displacement is the vector sum of the individual displacements. In this case, the total displacement is the vector in red. Notice that vectors are added up head to tail, or I would say tail to head. To find this distance, we need to apply cosine law, which is a squared equals b squared plus c squared minus 2bc cosine a. And we apply the formula and find that this distance is 29 meters. And furthermore, we need to find this angle here, and that is because displacement is a vector quantity, and as we learned from the previous slide, vector quantities involve both magnitude and direction. So how can we find this angle? To find this angle, we need to find angle P first. Therefore, we applied sine law, which is right here. And we find that angle P equals 19 degrees. And how can we find this angle, the smaller angle? And we can find the smaller angle by subtracting 19 from 33. And that is because this line is parallel to this dashed line. So this bigger angle is 33 degrees, and also we found that angle P is 19 degrees. Therefore, the smaller angle would be 33 minus 19, which is 14 degrees. And therefore, the total displacement is 29 meters, 14 degrees north of east. And here's the homework. And that is the end of the presentation. Well, I would say that this lesson is pretty easy since it involves a lot of things that you learn in your grade 11 physics course. I would say that grade 12 physics is pretty similar to grade 11 physics. So don't worry about it. And yeah, that's about it. Thank you for watching, and I'll see you in the next episode.